Okay, let's start the tutorial. Welcome to the second tutorial of the day, of the second day of the Flower Summit. My name is Daniel, and this is my colleague from TUM. We are both master students at Technical University of Munich, and we will want to give you a tutorial about how to federate your machine learning in iOS with Flower. So this is, yeah, the slide where I just mentioned you before. And let's start by recapping the tutorial yesterday about what is FL. Let's start with the centralized learning, the current infrastructure in the industry. It's centralized, and the sensitive data is uploaded to the server, which means if you're like using your Apple device for recording your sports and for example your health data, if you're like recording it, it cannot be learned beforehand with centralized learning because due to strict data protection regulation. But now with federated learning, you can train it with federated learning, and the training will happen locally, and only the model parameters are aggregated in the server. So it gives possibilities for you to learn your financial data. All of this training, sensitive data can now be trained using federated learning. And this is cross-device federated learning settings. And the purpose of this tutorial will tell you how to federate your machine learning models with Flower. So let's jump right out into the code tutorial. I will show you how to use the new Flower iOS SDK. And due to time reasons, I will give some restrictions to the tutorials. For example, we will focusing only on how to federate your machine learning processes. So the scenario would be you already have your machine learning running with iOS, and then you want to federate it using Flower. So for the tools that we are using for the tutorial would be an Xcode, which would be we are using Swift as our programming language, and for the data set is MNIST, and the ML model would be the MNIST classifier. I will just jump into my Xcode, and let's start coding. So what we are trying to build is a very simple UI that lets you give a server host name and a port. This is only for the front end, and then there's a button called Start Federated Learning where it calls the Start Flower client. So if you can see here, there's a button, and then it calls Start Flower client. This is where the main things will be going on. So this is where you start and use Flower. So let's jump into the app logic, and then this is the Start Flower client that we want to implement. Okay, so before we start coding, I want to give you like some explanations about the utils folder. So here we have like the MNIST. Since this is CoreML, and Apple is notoriously known for being a closed source, so we need the CoreML is also closed source, so we need to do things manually, unlike PyTorch or TensorFlow, where you can just load the data from the datasets and you can get the preprocessed data and so on. We need to do this manually. This is happening in data loader, So we have like two training data sets. This is MNIST training dataset and MNIST test datasets, which I downloaded from the PyTorch from the TensorFlow dataset and compress it into LZFSE. So it's compressed and will be bundled into your app when you are deploying it. Here it happens everything where you're just extracting and so on. And then this is the MNIST model where the your model, your CoreML model, and it can be trained on device. So this is your setup, your machine learning setup, and now let's use Flower to federate learning in iOS. So first of all, since we have training datasets and test datasets, we want to load them into the app. So in order to do that, we just use we just call the function inside the data loader. So we just declare a variable called train batch provider, and then we call the data loader, and it's calling the train batch provider. So the progress handler is a closure. Right now we don't need anything to do for the inside the closure, so we just give it empty, and then we just the same thing, just load the test datasets. So this way we load the training datasets and test datasets. Oops, there's an error there. You need to okay. So, but since we are using mobile device, if we are calling this function, it will run inside the main thread. So the UI gets unresponsive. So in order to make it responsive in the foreground, we just make a new thread and let it work on this on the other thread instead of running everything on the main thread. So in order to do that, just use dispatch queue and then global queue. Okay, it's great. Now you have a thread that is this one here. Forgot the async. But oh, there's no. Okay, so we have a thread, and then we put our training datasets inside, and now let's put this all together and pass it to the Flower client. So in order to do that, just create a data loader that's called ML data loader. This is part of the iOS SDK. So you just put everything inside. Great. Now let's do the main part. We need to load the model as well. In order to do that, imagine the model is being deployed into the app. So you need to call this model inside the function. So you need to get the URL for the CoreML model, where the CoreML model is being located. So let's do the loading part. Resources. And then we know that our MNIST model is being called MNIST model. And then the extension of the MNIST model is ML model. And this function called bundle main URL is returning an optional, which means if we didn't find it, then it will return nil. So just say if it's not nil, then we can load our Flower client inside. So this means the bundle, if it returns not nil, not null value, then we start doing loading the Flower client. So let me first, before we continue, I want to give like a short introduction about CoreML. So the CoreML has a function as a new feature since 2019 that you can.
There's a question
Okay.
saying, are you using a pre-trained model to get the initial parameters?
This is not a pre-trained. This is everything is being it's only initialized with TensorFlow, so it's not trained. It's just being converted into CoreML model. Okay, so let's continue. Where am I? Okay, so let's start out to short introduction to CoreML. It can be trained on device locally, but it's not as easy as with TensorFlow. So in the way you need to know the weight and parameters, you need to know the name, because if you're like creating the layers inside CoreML, you need to give it a name, and the name and the weight array is being stored inside the ML model as a key value pair. So if we don't know anything about the names, then it's becoming very difficult for us to see what weights are being trained and so on. So in order to do that, inside the utils, there's a CoreML helpers that extracts the names from all of the layers that is inside our ML model. So that's why there's an overhead before we can do our federated learning with Flower. Okay, so let's just call it inside this CoreML helpers, there's a struct named ML model inspect where it opens the model and then it looks for the name of the layer that is inside of the ML model. Now let's just call it and put everything inside of our app. In order to do that, just initialize a variable. I just call it model inspect, and then so notice we have an error here. It says call can throw, but it's not marked with try. So when the data is not there, then of course it will return an error. So we need to handle that. Right now, we just create a very simple do catch try, do catch closure, and then just print out any errors that is being printed, just print out the error that is being that is there if there's an error. So great, now just call the layer wrappers function inside the model inspect. And these layer wrappers will then be passed to the Flower client. So inside the iOS SDK, there's a default Core ML Flower client that is being implemented there. So if you want to federate your iOS machine learning, you can just use that. Right now, the only possible way to do on-device training with iOS is through Core ML. TensorFlow Lite only supports inference for now. But in iOS SDK, there's an abstract or a protocol for creating a Flower client. This is also similar to what we find in Python. So if in the future the TensorFlow Lite can support on-device training, you can just extend it with the protocol. So you can just extend your Flower client modularly. Great. So now we have our data sets, and now we know the key value pairs of our layer names and the layer weights. Now the only thing to do is just initialize our ML Flower client. So this is the ML Flower client, which is inside the Flower iOS SDK. It expects the layer wrappers. We just put it here, and then the data loader is the data sets that we have. And then it expects a compiled model URL. What is the difference between ML model and compiled ML model? So the ML model will be compiled and optimized before you can do machine learning inside the Core ML. This is how Apple wants to do it. So in order to do that, there's a function called compile model in ML model. So it's provided by Apple. So let's just put it here. Let's declare a compiled model URL, and then we say, okay, ML model, please compile our model. Compile model. Okay, so let's yeah, no. Great, now we have initialized our ML Flower client. The only thing to do is we need to create a gRPC client. It's also inside the iOS SDK from Flower. Let's do that, and then we can just start our federated learning. So the Flower gRPC expects a server host and a server port. So as we have mentioned before, there's a host name and port that we can input within our UI. It is being stored here, so you just call it there. We just pass the host name and port from the UI into the Flower gRPC. That's how you initialize the Flower RPC. Now, let's start the Flower gRPC. To do that, just call Flower gRPC.start Flower client. And the function start Flower gRPC expects an argument called client. This is where we put in our ML Flower client. Great. It's done. So we have a Flower. In this way, we can federate our machine learning in iOS with Flower. Let's get back to the slides. To summarize everything, the main things, the steps to do in order to federate your iOS ML project. The first thing is to compile the ML model into the ML model C, and then you initialize the Flower client and pass your dataset as an argument. Then you initialize a gRPC, a Flower gRPC, and then you can start federated. You can start training your model federated. So now we go to the demo.
Okay, yeah, with respect to time, since I think we're almost running over time, I think we should just quickly jump into the demo.
Okay.
Right. Yeah. Yeah. I think in 5 minutes I can wrap it up. Can you open the simulator?
Yeah.
So we already prepared now several different devices. For example, we have Daniel's iPhone here, which has the current app deployed on it. And now we're going to start an additional simulator running out of Xcode, which runs the same code in a simulated environment on our MacBook. Yeah, so that's our simulated iPhone. So that makes like our second device. And our host name is
localhost.
Is localhost, yeah. And then we need to start our Python Flower server. And then we're already ready to go. And hopefully it works. Okay, now we're going to start both the simulated device and the real device in our hands. So that's our real device. It's basically the same application as you can see here. Did you already start?
Yeah.
Yeah, and as you can see, it's already working. And yeah, it's similar to every other device you would use with Flower. And by the way, if you're interested in the internals, what happens in there, we also implemented an abstract class, which you can extend with your own benchmarking, where you can track and log everything, what happens. And in the end, we will create a JSON file, which you then simply can airdrop or export for further analysis. But yeah, that's for the demo part. There's one important additional part, which we wanted to mention, which is the part about future work, because actually the only thing which is keeping us from using what we implemented in a full-on production mode is the background processing on iOS, because there are two classes whenever you want to run something in background. Because right now we are required to run the application always in the foreground. It always has to be open, the application. Ideally, we would like to also have like some background processing and choose the devices. However, Apple makes our life a little bit more complicated there, because if we have a look at the documentation, there are two types of how we can do background processing in general on Apple devices. There's the app refresh task, which is typically like per app launch, get like around 30 seconds whenever you want to do some refreshing in the background. And there's the background processing tasks, where you're allowed to do like heavier computation, which is also can take up several minutes. However, there are some influencing factors which influence the background processing schedule. For example, battery life. If, for example, the user has like energy saving mode on, or if the phone is on the edge to die, then we're not allowed to do any background processing. The second thing is the background app refresh in the settings. If a user just says no way, then we can't do anything with that. The third thing is the on-device predictive engine. So Apple trains a model on your user behavior and a user usage pattern. Now, for example, if you're always using our Flower application at 8 a.m. in the morning, and we now register a background task which is scheduled to have around 10 minutes, then Apple will give the processing power to that application around 7:50. So it is completely, or it's about to finish before you actually press on the app. Also, what is very, very important, that the app is still in the app switcher. That's when you swipe up your phone and you kill the apps. Your Flower application would still need to be in the app switcher. And last but not least, there's also a system budget, which all of the apps have to share, which makes our life very, very complicated, because while we develop that, we also built like a very small application to just try out. And that's a very common example. The expectation is here, what we try to do is like we cyclically, like every 3 hours, we wanted to have like a background task, which we registered. And our expectation was, okay, every 3 hours, we get like this slot where we can do background tasks. However, in reality, we don't know, like it's not in our hands how the scheduling works, and we can't just deterministically say whenever a background task is about to happen or not, which makes our life very, very hard. Because this means our application always has to be in the foreground and has to be open right now. Yeah, and I mean, that's like the current only limitation, which really hinders us from using that in full-on production mode. But yeah, with that being said, if there are any questions, feel free to ask them. And yeah, thank you.
So there's one question online. Did you develop an iOS SDK or just a library for Flower? And can we extend and customize it in the future?
Yeah, the iOS SDK implemented it, so it is there, and you can use Swift package manager to import it into your project, and it's modular, so you can extend it whenever you like. The example that I give here is a default one. You can just extend the protocol. You can just create a class that is conforming to this protocol. Flower client, it's the same as Python, so it's modular.
Maybe a question from me. The background schedule tasks, is that like, can I at least expect that it will happen at least once a day? Or
yeah, actually, I wrote just a Hello World application for myself, which always sent me like a notification whenever my app got like background processing tasks. The only thing I did, I showed like a pop-up for myself. And I let it run, I think, like for a couple of days, and I tried to have as many tasks as possible, and I only got like 3 tasks throughout the whole week. So I think if you play, but I mean, the problem is with the predictive engine, if you download a new app, then the predictive engine thinks, okay, this app is currently not that important for our user. He just downloaded it. Yeah, so that makes our life a little bit harder. Of course, you could also play around with like sending silent notifications, which trigger notification, which tells the user we would like to have you now in this epoch of training, but I mean, that kind of defeats the purpose again. But yeah, that's the only limitation right now.
so does that mean when it's an app which I regularly use,
Yes,
we get more background?
yes, yes,
So if I have a successful app and I just build it into it,
yes,
I get
yeah,
background tasks.
yes. If it's important for the user, like, yeah, if you tend to use the Flower application a lot, it will get a lot of background processing tasks. And also those background processing tasks, you always have to specify the time frame, how long this task will take, and then they will shut down your background processing task, and then they also optimize that like to your usage pattern. Any other questions? Okay, cool. Thank you.